right. Welcome, welcome, welcome. Good morning, good evening, good night. Uh, First, couple of some housekeeping. Use the Q&A panel. The webinar is being recorded. Yada yada yada. All the usual stuff. So the agenda for today, we're going to talk about the general, how to optimize your infrastructure, either your existing or your planned, your new, the infrastructure that you manage, how to optimize it and fine tune it, especially considering new applications which are coming along. So we'll be touching about IPTV systems. We've been using IPTV for a couple of years now, but we tend to see a lot in the field. We tend to see quite a few issues with it, and when things go wrong in IPTV systems, they go wrong spectacularly. Same can be said for things like casting, or Chromecasting or Apple TV. They tend to fail spectacularly. So we want to take this opportunity today to dig a little bit deeper into it, into why it happens and how to fix it. Voice over IP, again, these are systems which are being deployed more and more in our industry, and they tend to be very tricky to optimize. So we'll touch on those as well. And then a bit more general health monitoring, troubleshooting aspects, and also where you can find a bit more further reading to dig a bit deeper. So without further ado, here we go. So general optimization. So in general, it's when it comes to networking, right? The optimization needs to start at the foundations, a bit like building a house. There's no point in building a very solid walls and a very strong roof if your foundation is not solid. So at the very bottom of it all is your RF health, right? Your how good is the space that you're working in, essentially. And a very useful, simple metric to look at is the airtime utilization. And every AP, if you look at the controller, every single AP will show you the airtime utilization for each radio. And generally, what we recommend is to look at these numbers and try to keep these numbers below 20% for 2.4 and below 1%, so essentially 0 or 1% for 5 gig, for the 5 gig radio. Now, this is a very, it's a very high level statement, very broad statement, right? So if you're running an infrastructure in the middle of a forest and there's no one else around you, then those numbers should be really low. Whereas if you're a city hotel, in the middle of New York, in the middle of Dubai, and then it's going to be very, very noisy. It's going to be a very noisy environment because all your neighbors are going to be broadcasting their own Wi-Fi networks. There's going to be other non-Wi-Fi interference, so this number is going to be up. But in general, we try to aim to keep those numbers at around 20% for 2.4 and around 1% for 5 gig. And the same thing on the right here, what you're seeing is a dashboard which or at least one part of a dashboard which we introduced in Ruckus Analytics 3.0, where the platform will actually tell you the average airtime utilization across the entire data set, whether that's the entire property or the set of access points and an AP group, and it will give you an average airtime utilization. Again, same conditions apply. Aim for 20% on 2.4 gig or 1% on 5 gig. One more thing I would mention is that this number will increase when the network is being used, right? So naturally, as you have clients connecting and downloading stuff and doing video calls, and so as the network is being used, this number will naturally increase. So try to look at these numbers, and when you're analyzing these numbers, try to do it when your network is relatively quiet, or at least when you're looking at access points, try to look at these numbers when there are no clients connected to the access point. So that's kind of the foundation. And what is the root cause of this higher time utilization? Like I said, when the network is being used, it's normal to see higher time utilization. But when there's nobody around, if you're in the middle of the forest and there are no clients connected, and your number is still, in the 30s, 40s, and 50s, what is causing that interference? Usually, it's you're causing your own interference. You have too many SSIDs. We see this very, very often, that especially when networks are being deployed, which is when they are being tested, you have, all kinds of integrators and different integrators wanting their own SSID and temporary SSIDs, temporary this, temporary that. You end up with a massive number of SSIDs, and they end up staying there more often than not. And the more SSIDs you add, the more that causes that takes up airtime. That uses up your airtime. The reason being, quick background, the reason being that every SSID must broadcast every 100 milliseconds. It must announce itself. It broadcasts a beacon. And it doesn't matter if the SSID is hidden. It doesn't matter how long the name is or how short the name is. There's absolutely no difference. If you have an SSID enabled, it will broadcast. And every single SSID will broadcast independently. There's a chart here which you can find from WLAN Professionals, which tells you, which is a calculator essentially, where where it tells you how many SSIDs you have versus how many access points you have on that channel, and how much of your airtime is being used just by the SSID. And any number above 50% or above basically means the network is unusable. So you can imagine that we're working in a very small spectrum here, especially if it's 2.4, where it's normal to have your network at 20%. So try to keep that number as low as possible. So what do I do then if I have too many SSIDs and I have all kinds of integrators wanting their own SSID? What do I do? So the best way to do it, in our opinion, is to use what we call group DPSK. It's a technology which is built into our platform for a couple of years now. So even if you have an existing platform, you probably have this feature available to you. It's available on Smart Zone and Ruckus Cloud. And essentially what it lets you do is combine multiple services. So you would say, I know what you're going to tell me, every service is on its own VLAN, but that's the nice thing about DPSK, in that you can have a single SSID, and then depending on the password, the passphrase that is being used to connect to that SSID, or depending on the PSK that they are connecting to that SSID, those devices will be dropped to the relevant VLAN. So if you have password A is for your AV control tablets, any device which connects with password A will be dropped into the VLAN relevant to the AV control tablets. But then if there's a personal smartphones, you have staff smartphones, you could create a PSK just for the staff smartphones. And if let's say it's called staff 1234, and any device connecting with staff 1234 will be dropped onto that personal smartphone VLAN. So there's no need to have a single VLAN for all your devices. Even with a single SSID, you can have as many VLANs as you want, essentially. The other way of reducing SSIDs is to enable the SSIDs only on specific bands. So rather than leaving it as default, where an SSID is created and it's enabled on both bands, go through the SSIDs and look at the applications for those SSIDs, and only enable the SSID on the band that needs them. So I have in-room tablets. All my in-room tablets, for example, are iPads, Apple iPads. Apple iPads will happily run on 5 gig. So turn it off on 2.4 gig and just run that SSID on 5 gig, right? Because there's no point in having it on both bands and causing interference to yourself on both bands. So just limit it to 5 gig. Or else do both. So use DPSK to minimize the number of SSIDs you have in general, and then look at the applications for each SSID and assign it to the relevant band. So if you have multiple, like for example the example that we give here, the services WLAN, all the devices connecting to that services WLAN are dual band, so 11N or 11AC or Wi-Fi 6. So they all can run on 5 gig. So enable it only on 5 gig. You don't need it on 2.4 as well, right? Normally, we recommend that the guest public Wi-Fi and something like a conference Wi-Fi, so conference SSID, we normally recommend having it enabled on both bands because you can never force a guest to use a modern device. So they may have an older device or single band device, whatever it is, and they will need to connect anyway. So if they have a single band device, they won't be able to connect to a 5 gig only SSID. The next topic, next hot topic, I would say, is VLANs. So VLANs are great. They allow us to segment large networks into small manageable chunks rather than have everything on one large layer 2. However, VLAN mismatches are probably the most common cause of issues that we see in the field. So on the RF side, it's usually what we were talking about just now, the airtime utilization, but on the wired side, usually VLAN mismatch is probably the most common cause of issues. And especially when switches are manually configured. So there are still networks out there where switches are individually configured, and that obviously is leaves it open to misconfiguration. This is why we recommend having the switches managed by Smart Zone or Ruckus Cloud as well, rather than manage the switches individually, because we normally have a lot of switches in our networks, but those and those switches, they have a fairly static configuration, a fairly common configuration. So it's best to let the Smart Zone configure them and manage them so that you can be sure that the configuration is contiguous across your entire estate. So back to the issues that VLAN causes, basically all it takes is a single misconfigured switch port, and that will cause connectivity issues that are very hard to diagnose because there could be just one access point along a hallway, one access point in a conference room which is misbehaving, but it's not obvious that it's misbehaving, right? And that will cause connectivity issues. So let's assume that the switch needed to be replaced. There was a 24-port switch. Now I need more ports. I put in a 48-port switch, but whoever put the switch in didn't configure the switch. They just put it in, plug the cables in. Okay, they saw lights blinking. They saw the access points coming on. Happy days, right? So they thought that everything is fine. Well, the access point is powered up. The access point may even come online depending on the configuration. So you will see the access point on the controller, but because those VLANs are not configured, anyone who tries to use that access point will not get anything, right? They'll be able to connect, they'll be able to see the access point, connect to the access point even, but they won't get the HCP, they won't get internet access, and all they will get is a very big headache for you because you need to troubleshoot and narrow down where that issue is. Now, obviously, the way to prevent this is to make sure that your switch configuration is correct and all your VLANs are configured correctly. But again, in Ruckus Analytics, this is one of the tests that Analytics does continuously. So it monitors your switches, it monitors your access points, and says, hey, in this port, you have one side where you only have VLAN 30 configured. And the other side where you have other VLANs configured. So there's a mismatch there. So that VLAN 30 traffic is not going to work. So with Ruckus Analytics, you can immediately tell where the misconfiguration is before it starts being an issue. Another way of monitoring this, so monitoring this in a slightly different way, is to use a feature called Smart Monitor, which is built into Smart Zone, where the access point will regularly check the default gateway. So whatever default gateway you have set on the access point, that access point will go out and ping it and check it every 10 seconds. In this case, as you can see, it's configurable. And if it doesn't reach that, it will shut down the SSIDs. So it will shut down the radios. So it's much better for the access point to fail completely than to partially fail in the case of having a mismatched VLAN. So that's why this is a cool feature that we have built into the Smart Zone, where this check will be done. The same way, the access point will reboot if it can't reach the default gateway. So again, this could be a health check for you as the admin, that you will see the access point rebooting every 30 minutes, right? So it could be an indication for you that, hey, there's a problem there. This access point is rebooting every 30 minutes. Why is it doing that? And that can be an indication that that there's a VLAN mismatch, right? So it's a matter of doing some root cause analysis there. Obviously, all of this will be logged in the smart zone. As long as the access point can reach the smart zone, it will report back to the smart zone saying, hey, I can't reach the gateway, so I'm rebooting, or hey, I can't reach I couldn't reach the controller, so that's why I rebooted. So back to the RF environment, the way to clean up basically your RF environment is to let the access points decide in terms of Wi-Fi channel, right? So don't try to set static channels. We've seen this in a couple of locations where the administrators, they were coming from different non-Ruckus environments, let's put it this way, and they were familiar with setting all channels statically. So we don't recommend that, especially in hospitality environments, for two reasons. One is that our auto-channel algorithm is really pretty good, and two, because our environments are constantly changing, right? Today there's no one around me. Tomorrow, a neighbor could build a hotel, a new property, and they're deploying their own Wi-Fi APs. There's a couple of hundred APs next to me now, which I don't have control over. So you want to make sure that you let your infrastructure be adaptive as much as possible. And we have a couple of ways of doing this. So one of them is using background scanning. So using a bit of a legacy way of doing it, where basically the access point will go out and scan other channels and then pick whichever channel has the least amount of noise. But we have a cool automatic channel selection feature called Channel Fly, which will use a lot more. It has a lot more parameters essentially, which influence the algorithm, and it will it has more emphasis on reducing co-channel interference. So even though a channel can be noisier, has more noise, but maybe it's better in a particular moment in time. So if you want to start using Channel Fly, there's a couple of tweaks which you need to do. You see the slider here, minimal, very often. So the channel change frequency. This is basically telling the controller and the AP saying, hey, I don't want you to change channels very often. So you slide it down to minimal. Or if you want to have the best possible channel selection at all times, then slide it up to very often, right? Slide it down to the right. We would suggest keeping it more towards the left, because the more you move it to the right, the more disruptive it becomes. As your network gets busy with your own real clients, especially if they're doing things like video calls and something which is continuous stream of data, your noise is going to increase, your utilization is going to increase, so the access point might want to change channel. You don't want it to do that, obviously, while there's a call going on. So try to keep it within the first quarter or first third of the slider as much as possible, to minimize disruptions whenever a channel change needs to happen. Then there's the second part, which is this this time scale, basically this time graph, where you can choose. You're telling the controller and the AP, do whatever you want. So in this, in these time frames, you can do whatever you want. You can change channels as much as you want. You can. There's no limit. So do whatever you want. And essentially, there's the graph at the bottom there, which shows you kind of the three situations where Channel Fly, or the three styles of how Channel Fly would work. So during normal operation, that's the green part. The channel changes will occur, but depending on how many clients are connected, it will not change. So there's a number. and that number is increased as you slide it up to very often, which basically says, hey, if there's X number of clients connected, then don't change the channel, right? And if you slide it all the way down to minimal, it's basically telling the controller, hey, I don't want you to change any channels if there is at least one client connected. So if there's even one client connected to the AP, don't change the channel. Right? So that's the green period. The full optimization period, as I explained before, is the period which you define using that time bar. And during that time, it doesn't matter how many clients are connected. There could be one client, there could be 500 clients connected to an AP. It will change channel if it has to, right? There's also a period when you reboot an AP, and this is important to remember as you're troubleshooting any issues, any performance issues, that when you reboot the AP or when you boot an AP the first time, channel changes will occur for 1 hour, right? So the first hour, the AP is still learning, it's still building its heuristics, so it will have to change channels for that 1 hour period. It doesn't matter how many clients are connected, and it's irrespective of the slider, the channel change frequency slider, whatever that is set to, doesn't make any difference. It will change channels for that 1 hour period. Another option is the inactivity timeout. Essentially, as the name implies, if there are clients connected and they have not been sending or receiving traffic for X amount of seconds, which is the configurable part, then disconnect them. Now, this may be good to reduce the load on the access point. However, keep in mind that a lot of smartphones and battery-powered IoT devices, they focus a lot on conserving power. So a lot of smartphones, or I think all of them actually, they will go completely quiet for minutes sometimes, for a number of minutes sometimes. I think the iPhone, for example, goes completely quiet for 4 minutes when it's basically sitting on a desk with the screen switched off. The iPhone will not transmit any data at all to the Wi-Fi network. So if you leave this number set to the default, which is 120 seconds, something like an iPhone, if it is actually 4 minutes, it will that iPhone will get disconnected by the infrastructure, by the access point, but the iPhone doesn't know it has been disconnected, right? So the access point will tell the smartphone, hey, I'm kicking you off the network, but maybe that phone does not hear that message, and it will think that it's still on the network. So that could cause issues, right? So what we recommend is to increase that number to at least 300 seconds, which is 5 minutes, which should cover most smartphones. There's an option called Wi-Fi 6, and it's a simple on and off. And essentially, it's, again, as the name implies, you're enabling support for Wi-Fi 6. If you switch this off, the access points will just function just like 11AC access points. Now, why would you want to do that, right? You just bought your shiny new access points and you want to turn off the one of the key aspects that they have. Well, the reason is that when Wi-Fi 6 was introduced and the first access points started appearing, there were some issues with some clients, some older clients, some non-Wi-Fi 6 clients, which were not able to connect. They were not able to even see the SSID. So that was causing a lot of issues, a lot of frustrations. So that's why we introduced this simple radio button where you can say, okay, so turn off support for Wi-Fi 6, and then and then that will support all clients, including Wi-Fi 6. Obviously, we don't suggest that you do this because you want the benefit of Wi-Fi 6, but there's the option to do that if you start seeing a lot of issues with Wi-Fi 6 support.
Hey, Andrea.
Yeah.
This kind of jarred my memory that we should put a slide in that says we should turn off 11A and B, right? That causes a lot of problems. What's the term for that?
The BSS min rate. Yeah.
Yeah. No. We turn off
OFDM
whatever.
Only?
Yeah, OFDM only. We should make sure, because some people, because that's still on by default. So it's coming. Okay.
Yep.
Oh,
it's coming.
Next slide.
Yeah.
Awesome.
Yeah.
I have to jump in a couple of minutes, guys, but I will listen to the recording. So thank you.
All right. Thanks. So yeah, so again, that's a very good point. So that's the next topic actually. So yeah, so disable Wi-Fi 6. Now, in terms of the coverage area, just never reduce the transmit power. Please don't. The way to reduce the coverage area for an access point to ensure that clients connect to the nearest access point is to enable these options that you're seeing here, which is called OFDM only and BSS min rate. What that does also, it prevents older devices, older 11B devices from connecting, and it turns off the very slow data rates, basically the 1 meg, 2 meg, 5.5 meg, 11 meg, it just turns them off. Basically, we're sacrificing the 1 or 2 11B devices which are still existing in the world for the greater good, you know, to be able to deliver better performance for everyone. And the way that this works is when you enable the BSS, when you enable OFDM only and set a BSS min rate of 12 megabits, you're basically telling the access point and the clients, if you can hear me at 12 megabits, you're free to join. But if you're trying to slow me down, if you're trying to slow yourself down, then you're too far away from me. So I don't want you to join the network. You should join another access point, right, which is closer to you. So this is what it does, and you can increase this number further. Then the drop-down box has, I think it's 12 and 24. You can increase it. The higher you set the BSS min rate, the smaller the coverage area is. So things like access points in a conference room where you tend to have a lot of access points and you want to bet the absolute best performance, you could actually increase this BSS min rate to a higher number, to 24, and then keep this number low to 12 megabits or even 6 megabits in areas where you want coverage rather than capacity. So like your back of house, for example. Another option to reduce congestion essentially is, funnily enough, called airtime decongestion. And what this does is it monitors the air, and if there are other access points already responding to a probe request, so basically a device requesting for connectivity, then it will, some access points will not respond essentially. So the access points within the coverage area of the AP will respond, coverage area of the client will respond, but those access points which are further away, although they could technically respond because they heard the request, they would not respond because they know, this guy is too far from me, there's another access point close by, so I will just ignore them. And that in itself reduces congestion. Similarly, there's the joiner SSI threshold, where you're saying only allow clients who are at least X dBm, so their signal strength is at least minus 75 dBm in this case, to be able to join. If they are lower than this, then they won't be able to join. All right, so let's jump into a couple of specific use cases or specific topics now. Meanwhile, are there any questions or comments? Okay, so let's start with the big one, IPTV and casting. Essentially, IPTV is it's hungry for bandwidth, right? So a full HD channel consumes about 20 megabits of bandwidth, and a 4K UHD channel uses about 40 megabits. Now I'm talking about channels which are transcoded from satellite signals or from terrestrial TV signals. I'm not talking about the likes of Netflix or YouTube or Hulu. None of that. Those are highly compressed and they're buffered. So that's something else. What I'm talking about here is live channels which are transcoded from satellite or from terrestrial, or even delivered directly over fiber to the property. So I'm talking about live TV channels here. So they consume a lot of bandwidth. Now, one channel is fine, 20 megabits, 40 megabits on our multi-gig networks today is nothing. But when you start adding up, generally you don't have a single channel in the property. You tend to have, a full set of channels, and that can add up quite quickly, right? So you have 600. In this example, I just took an example here where we have 20 channels which are full HD and then 5 UHD or 4K channels. That's a total of 600 megabits. And that 600 megabits, those are continuous. That's continuous traffic being thrown at your network. So the thing with IPTV is that it's all multicast. Multicast is a bit of a headless chicken, right? It doesn't know where it has to go, so it goes everywhere. The way to control it is to use IGMP. And the symptoms that you would see when your IGMP protocol is not configured correctly is it's pretty much the same as having a network loop. You start seeing very high utilization on all the ports. You start seeing some devices crashing, or their port is saturated. Maybe there's some older devices and they only have 100 Met port, so they get saturated very quickly. So yeah, it's just general bad health of the network, and this is across your entire network. It's not only where a TV is plugged in. It's multicast. Without IGMP, behaves like a broadcast, which means that it goes across your entire network. So this will take down an entire network very, very quickly. So really make sure that this is set up correctly. And for IGMP, essentially, it's a very simple protocol to set up, really. And the key element is that the ports must have IGMP snooping enabled. So all the ports where you have a TV plugged in, whether directly or downstream, must have IGMP snooping enabled. And you need to have a querier, an IGMP querier, which in Ruckus ICX parlance is called multicast active. That's basically the command. That's all you need to do. And finally, fast leave. Be careful of fast leave, because essentially what fast leave does, fast leave is an IGMP feature where as soon as a TV, for example, leaves the subscription for a particular channel, the switch will stop sending down that channel, down that path. Now, if you have a 24-port switch and you have 24 TVs all watching the same channel, and you have fast leave misconfigured, if you change channel on one TV, all the other TVs will stop receiving that channel. Will start glitching until it subscribes again. So anyway, a lot of bad health essentially.
Hey, Andrea.
Yeah.
Yep. Just on this point, it's good to note, especially if you guys will have partners on the webinar, that if someone is interested in this particular area of optimization, we did a family day training workshop last year. So we have a whole, deep dive on this particular topic available if there's some partners interested.
Really, can you send me the
Sure.
link or the reference to it? So I'll just add it to the slide here. So,
yeah, we'll do.
So essentially, there are three types of configurations for IGMP, right? So at your core, essentially where a TV headend is configured, make sure you have multicast active enabled, which is the IGMP querier. Use the router interface command and set an IP address on that interface, because the IGMP querier needs an IP address, needs to have an IP configured on that VLAN, and make sure that fast leave is not configured, is not enabled on this switch and on this port, because this is something, obviously this fast leave is definitely not something that you want to have configured on your core. At the other end, on your access switches, if you have a single TV connected to a single port, then you can enable fast leave. Obviously, you need to enable multicast, which enables the IGMP snooping, and then you would need to enable, and then you can enable multicast fast leave. If you don't enable it, that is okay as well. It just means that as you're changing channels, the switch will take some time. The switch will continue sending previous channels to the TV until it times out, essentially. So as long as the TV can handle multiple streams, then there will not be any impact. But if you do enable multicast fast leave, obviously it's a bit more clean in the sense that as the TV changes channel, the switch immediately stops sending the last channel to that TV. If you have many TVs connected downstream from a port, so let's say you have a switch connected to an H550 wall plate AP, and you have 4 ports there, and you have 4 TVs, 1 TV plugged into each port. Make sure you do not configure multicast fast leave in this case. You still need to enable multicast on that port because you still want to participate in IGMP, but fast leave should not be enabled in this case. Next up is casting. So casting or streaming media device, CMDs, they have many different names, but essentially we're talking about Google Chromecast here, which is something which has exploded in our industry. Normally these are not problematic. They are basically they're Wi-Fi devices. They just stream data off the internet, and they're quite well behaved, except for when Google pushed out an update and broke a lot of networks. Essentially, what happened was Chromecast are constantly announcing themselves. As long as they're connected to the network, they will continuously announce themselves. And at one point, there was an issue where these devices would buffer a lot of announcements and then transmit it all at once, which was causing networks to fall over, basically. So the other issue here, and this is something that obviously our partners do really well, in the sense that they make sure that one Chromecast can't see another. So if I am in room 201, I will only see my Chromecast, because keep in mind that Chromecast and Apple TV and all of these streaming media devices, they weren't designed with hospitality in mind. They were designed with your home and my home in mind, where you would only have one or two dongles. But what happens when you have tens, hundreds, or thousands of dongles, all of them announcing themselves, saying, hi, I'm a Chromecast, I'm room 201, I'm room 202, I'm room 508. That's a lot of traffic on the network. And also it's a bad user experience, it's a horrible user experience that the guest will see essentially 500 different Chromecasts in the list, and they need to scroll until they find their own. It's obviously not a good setup, also because that means that I can be in the lobby and cast whatever content I want to cast to any room in the property. So obviously this is not something that we want to do. However, there are solutions to it. And again, our partners, they pretty much all of them have solutions to it using dedicated gateways. Some brands also have their own proprietary dedicated gateways, which they implement to make sure that you as a guest can only access the Chromecast in your room. In terms of networking, there are a couple of things which you need to do to optimize them and basically to keep them well behaved on the network. First of all, only enable them on 5 gig. So you would create a dedicated SSID, whether it's a DPSK SSID or their own standard SSID, doesn't matter. Just only make sure that it's only enabled on 5 gig. So the Chromecast device will only connect on 5 gig. Because if it connects on 2.4 gig and starts streaming a 4K movie of Netflix, that's generating a lot of airtime utilization on your network, and is doing it on 2.4, where we already don't have a lot of space to begin with. Enable client isolation to make sure that the Chromecasts do not see each other. Obviously, you would whitelist the gateway in that case. And on the switches, enable MDNS filtering, just to make sure that the Chromecast can only do MDNS, and there's no other multicast traffic coming out of the dongles, which would cause a lot more, would cause issues the same as the IPTV devices would. Next up is a personal favorite topic of mine, is voice over IP. We see a lot of voice over IP being deployed in hotels nowadays as well. And but first of all, before we go deeper, I want to establish what it is and what it is not, right? Because many people, when they hear voice over IP, especially nowadays, when they hear voice over IP, we think about Teams calls, Zoom calls, Skype calls, those kind of things, or even Wi-Fi calling. That is not what we're referring to here. Those applications, so things like Teams, Zoom, Wi-Fi calling, those are pretty much standard Wi-Fi traffic. That's how we treat them. These kind of applications, they are designed to run over bad networks because they're designed to run over the internet, even Wi-Fi calling to a certain degree. We do have some fine tuning on Wi-Fi calling, but Wi-Fi calling is something which is managed by the operator, right? By the owner of your SIM card, essentially. So we cannot really do much about that, except for making sure that there's a healthy Wi-Fi network going back to the original, to the first slides, essentially. What we can optimize are things like ASCOM handsets, are essentially SIP traffic, right? So you would have a PBX either on-prem or in the cloud. It would be private. So these are private extensions, essentially dedicated handsets which connect to the Wi-Fi and use the Wi-Fi network as their infrastructure. So that's what we're optimizing here. This protocol is the #1 toughest protocol to optimize for, and it is the hardest one. And there isn't a single fix-it button. So if you are seeing issues with voice over IP, or if you're thinking about deploying voice over IP, and you start seeing issues, don't worry. That's very common. I would say it's more common to have issues with voice over IP than not. So there's and with voice over IP, it's a multi-layered approach. So you would need to make sure that your RF infrastructure is healthy, but then you would also need to make sure that that the rest of the network is healthy as well. And it goes back to what we started with, right? Your airtime utilization. For voice over IP, more than any other application, if you start going above these numbers, it will hurt. Your performance will be bad, and it will be detectable in the voice calls, to the extent where you won't be able to have voice calls over the Wi-Fi network. Some other optimizations are pick a band and channel plan. This is general network best practices, but it's especially applicable to voice over IP because a lot of these handsets, the handset manufacturers, you can manually configure which channels to use on the handset. So, you would say, okay, so I'm going to run my network on 1.6.11 or 1.5.9.13 if you're in Europe or in Asia, and you need to set this channel plan on the handset as well, right? Because if you just leave the default is probably scan all channels. What's going to happen is that the phone has to call out and scream out on every single channel, looking for the next access point as you are roaming, walking down a hallway. That's going to take time, and that's going to cause issues with roaming. So just make sure that whatever channel plan you decide on, make sure it's set on the controller as well as on the handset. Some other optimizations: enable 11K, enable 11R, as long as the handset support it. Most modern Wi-Fi, voice over Wi-Fi handset will support 11R. Otherwise, they wouldn't be worth their salt, frankly. And 11K is also very important in this case because it allows the handset to know what the next access point is running on. So what channel the next access point is running on. So it will help the handset say, okay, so the next access point is actually running on channel 4, and the other one is on channel 1. So I will only scan on channel 4 or channel 1. I don't need to scan on all the channels that you gave me, that I'm allowed to scan on. Use WPA2 with a passphrase. Obviously, don't use an open network. You could use .1x, but that could introduce a bit more delays in roaming because it needs to go back to the radius server. But either use WPA2 with a single passphrase, or ideally use DPSK, again, what we mentioned in the beginning, to make sure that that every handset has its own pre-shared key. So if someone, an employee, gets in a bad situation with the company and walks off with a handset, now they have the PSK if they want to, if they have the means to find out the PSK from that handset. And now you're in a situation where you need to go around all your other handsets and change the pre-shared key on those other handsets. To avoid that, use the PSK, where you can define a PSK for every individual handset. So if that employee walks off with that handset, just delete that pre-shared key, and that PSK, that pre-shared key, becomes useless now. Also, make sure that client isolation is disabled in this case, because the way that voice over IP works is it's peer-to-peer. So you want to make sure that if you have two Wi-Fi handsets talking to each other, they can actually talk to each other, because if you enable this option, they will not be able to talk to each other. Maybe the voice over IP system will see this and will try to go through the PBX, depending on the capabilities of the PBX. But again, that's one extra step, one extra hop, which you don't want to which you want to avoid as much as possible. And finally, set the priority to high. And I think we touch on this at a later stage. A couple of other options. I'm not going to go through every single one of them, but essentially these are best practices which we recommend to set to optimize voice over IP over Wi-Fi. So the priority, by default, when you create a new SSID, the default is high, and setting the priority to high gives it 4 times the airtime as WLANs set to low priority. Now, the priority should be set to low to deprioritize general use SSIDs like guest WLANs and corporate WLANs, and only set high priority for those SSIDs which are related to latency critical applications, one of which is voice over IP, and also something like IoT. So if you have Wi-Fi light switches, for example, make sure the priority on that SSID is set to high to make sure that that button press is delivered as quickly as possible. And the way this works is what this effectively does is that if there are 2 devices wanting to shift traffic at the same time, the device which is connected to a high priority SSID goes before the device which is connected to a low priority SSID. So essentially, that's what you're doing when you're setting high and low. If all your SSIDs are set to low or all your SSIDs are set to high, there's no difference, right? As in, there's no prioritization at all. It's not going to slow down anything if your SSID is set to low. It's just a priority. So if you have something with a higher priority, it will allow it before something which is at a low priority. And finally, some health monitoring and troubleshooting. We have the Ruckus Analytics platform, which has a built-in automated self-testing feature where you can schedule a self-test for individual APs. Now, the issue here is, you have access points all around your property. You probably have hundreds or thousands of access points. It's impossible to test every single one of them constantly. So maybe there's a cable which is failing, or maybe someone has put up a wall in front of the access point that you had installed and you don't know about it, or they installed something which is causing interference. So you want to make sure that your network is healthy constantly. So rather than going around and checking individual APs manually, you can schedule actually a test through Ruckus Analytics where the access point will self-test. And access points will even test each other. So neighboring access points can test the access point next door to make sure that the RF is working well. So 802.11 authentication and association, so connecting to the AP is working, that the pre-shared key is set correctly, and there's no issues with getting that connected. Captive portal is popping up correctly. I can get to the HCP, I can get an IP, I can resolve URLs via DNS. And I can also, and it will also do a speed test, right? Simple speedtest.net, and it will report back what kind of performance you are seeing. And it will give you an overview, a score. So as you can see here, we can see that 80% of our APs passed 802.11 authentication, but only 60% of them, I should say 50% of them, I managed to get to the DNS to the DNS test. So which ones are the faulty ones? So you can drill down and it will show you exactly which AP has failed at which point. So you can see here we have those 4 APs with a big red fail, saying that those 4 APs have failed the PSK test. So you can go and troubleshoot those 4 specific APs. You can schedule this to run daily, weekly, hourly, even. So it's a good tool to have to self-test your network and make sure that the network is constantly available for your users and your guests. If you're interested in bit more further reading, we have a set of configuration and design guides. It's a compendium of 5 documents, which you can find on our website. And these are written and designed specifically for hospitality. So you can find the unique client design, the unique requirements that we would need for hospitality, for hospitality environments, unique environments that we have, conference rooms versus guest rooms versus elevators versus outdoor areas, pool areas. How do you handle all these environments? How would you configure your switches? How you would configure your controller? And also how to monitor and troubleshoot the whole environment through analytics. So yeah, now it's open to questions, and thank you very much for your time. And then we have 10 minutes for questions.
Okay, nice dogs. So you're using the new graphics, nice, awesome.
I thought it was a dead cat in the beginning, because the other one, the one in the back, it has red around its mouth. It it seems very brutal, this picture. I think I'll change it.
Yeah, it's a big progress versus some other dogs we had last year.
Yeah, absolutely.
We had poodles, I think. But
yeah, cats.
So time-wise,
comments.
I think we're good, right? I think we're gonna fit into the scheduled time.
I guess it's 1 hour, no?
Yeah, with questions, so we should aim for a bit less. Yeah.
So this was about 50 minutes.
Yeah, Andrea, one question. This is based on 6.1 software, right? Or for example, if a customer is in a legacy situation where they have I don't know, maybe 3.6.2 zones and a mixed solution with Wi-Fi 5 and Wi-Fi 6 APs, probably could be a question about it.
Yeah, good point. Good point. So I didn't focus too much on the version. I think everything that I mentioned is from 5 to 1 and above. So obviously for something like Wi-Fi 6, for example, the Wi-Fi 6 option is not available in 3.6 because we didn't have Wi-Fi 6 back then.
So I guess that channel fly
yes,
proved behavior is different in legacy zones.
Yeah. So would you suggest that I should add a note to only use channel fly on 5.2.1 and later? Would you suggest that?
Otherwise, background scanning, right?
Mm-hmm.
Yeah, I think we can mention that.
Okay.
Yeah, like a spliner or something like that.
I'll just put it nice and small here.
It's a precaution.
Yeah.
Same as the use of analytics, right? Because only analytics is available in 5.1.2 version 4, right?
Analytics is 5.1.2. Yeah, that's correct. Yeah.
Yeah, somebody would say, okay, I have plenty of APs. Some companies are still using H500s and R300s.
That's great. We'll sell them.
Some,
We'll sell them new APs. We can't deliver it, but we will sell it to them.
It's better to move forward.
Exactly. Yeah. I mean, at the end of the day, yes, that's kind of the message that we're giving here. Obviously, we're positioning analytics as a solution. But if you don't have the infrastructure to support it, then hey, it's time to upgrade. You don't just upgrade just to get Wi-Fi 6. You upgrade to get
Analytics.
all the other things that come with it. You get IoT, you get analytics, you get cloud support, you get all the other things as well. So
if they want to take advantage of all these things, they need to move forward.
exactly.
No other option. Okay, good. Thank you, Andrea.
Thanks. Thanks for your feedback. Ethan, any comments?
I think so far so good for me. I just have a question. What kind of, like, let's say I want to do the recording for the webinars. Webinar. What kind of software that you guys using?
Recording for the webinar,
so-
meaning?
Yeah, because I heard
Yeah, I think
Emil and
it's added
Sendu says
question.
we are able to like pre-recorded the session so that then send it to Adams to do
Right.
it.
So Ethan, we did have that possibility last year, but there is a feature we're using On24 first of all, right? So On24 allows you to do pre-recorded sessions, but they're a bit wonky and the whole thing doesn't always work as it should be. Since last year, since we had those problems, we are doing just live sessions.
Okay, understand. So then I will do it then.
Yeah.
Because I was thinking doing the pre-recording, I can better manage the time. But it's okay now.
Yes and no. I mean, it actually that depends on presenters, and I'm most of RTF presenters prefer live sessions because I tried to. I thought that pre-recorded sessions would be improvement last year, so I rolled this out, and a lot of them pushed back, saying that they really don't want to do it. So at the end we did both, and then when we had technical problems, we reverted back to live.
Okay, I got it. Understand. No worries.
Okay.
I'll do live then.
Yeah, you should have my calendar invite, right? With all the links and
Yeah. I have.
Yep. Okay. Have you ever done presentation in On24?
No,
Okay.
I haven't done it yet.
So let's grab some time, maybe tomorrow, I can show you the features and functionalities that you need for presenting, and sort of we can test drive.
All right.
Yeah. Okay.
It will be good.
It's a bit like our smart zone, Ethan. It works much better than it looks.
Okay.
Yeah, that's a good way to put it. Yeah, thanks. And Ethan, also, I'm just sending reminder to you, Senthil and Emil. We need to really send reminders to your partners, because we have low registrations in APAC, and that's I think that maybe that's because when invitation went out, maybe it was not the best day, or it's just sometimes we get low open rate. Yeah,
I noticed that. That's why I think 2 days ago I bring this up to the team Wasu and the SSP team here, so to get them to blast it out to all the partners, especially those tier 2 partners.
Sure. I will send you also graphics for like LinkedIn post and social media post if you want to do some organic posting as well.
All right.
Okay.
It would be good.
Right. Thanks. Okay. So I think we're good. So Andra, design wise, I think the slides look good, but when you finish like edits, please send the deck forward to me. I'll just go and make sure it's optimized in terms of graphics, and I'll just do the usual checks, and I will also change the format of the frame to basically I'm doubling the size of the PowerPoint frame to make sure that the on 24 because 24 is compressing the slides. So you know, for sampling, I'm increasing the resolution so that the output quality is good, because that was one of the problems last year. So so don't be surprised when I share the final deck. It will have a bigger slides, basically. I mean, it looks the same. It's just, you know, in the layout settings, it's going to be bigger. Okay.
Okay. All right. I
So,
think
guys,
I'll
thank
have
you
it
very
ready
much.
by. I think I'll have it ready by end of, let's say, end of play tomorrow, because I have loads of codes. But I'll send it to you by end of day tomorrow.
Awesome. Thank you.